Today we're going to examine nonparametric analysis. This will be divided into three videos, one here on the theoretical background, a short one to collect some information, and a third one showing you the mathematical calculations associated with chi-square. So when we think about non-parametric analysis, this is a little different than the work we've been doing, and I've made this little graphic to visually represent what I'm talking about. So one of the first things we started with was we took interval level data and we compared it to interval level data on the x and the y, and we had what was called a correlation, relationship between two variables. When you take your next class, you'll do a little more sophisticated version called the multiple linear regression. Then we moved on to looking at categorical data as our independent variable or our x, comparing that to some level of interlevel data. For example, a pre-test, post-test situation where the categories were pre-test and post-test, or a male, female, or a race ethnicity, all in the categories. And then we looked at interval level data as the dependent variable. We did the t-test, and the t-test was two levels of categorical data. We also worked on the ANOVA, which was two or more categories of data. Your future learning will include the ANCOVA, the MENOVA, and the MANCOVA. Today, we're going to look at categorical and frequency. So this is bucket data only. And so stuff that fits in buckets, and does it meet what is observed and expected? This is called the chi-square analysis when we use nominal level data for the purpose of the analysis. So the chi-square is a non-parametric test, and data is not over a curve. It's just what's fitting in the buckets. There's a trait or no trait. It's a yes, no. There are no scores associated with it. We're just basically talking about frequencies. So we're counting the times something might happen. And when you're doing the analysis, you're always comparing actual observations in the study with the expected observations. And expected can mean very different things relative to what the study is. So I'll give some different examples of how we determine what expected is. Sometimes it's pre-test data becomes the expected, and the post-test would be the actual. When we look at the examples, we'll figure that out. And the chi-square analysis estimates a factor other than chance, accounting for an apparent relationship. You're more likely to establish significance when you have a good relationship, you have a sample size that's large. This is the formula. So different than the SPSS work we've done, this is going to be calculated by hand or calculated using a spreadsheet. I'll teach you how to do it during a spreadsheet. So the chi-square, and the Greek letter chi looks like an x. And so the formula is the sum of the observed minus the expected squared divided by the expected. So the calculation of the chi-square is pretty straightforward. You compute the expected frequencies. You use actual values, not percentages. This is really important. Actual values. Use the n, not the percent. You use the chi-square formula. You calculate degrees of freedom, which is rows versus columns minus 1, multiplied times each other. You use a table to determine what the critical value is, and you compare the critical value to the chi-square value. If the critical value is greater than chi-square, then p is greater than 0.05. There's no statistical difference. And if the critical value is less than the chi-square value, then there is statistical significance. It's the same idea we've been talking about. Are you past the edge of the curve? The chi-square kind of has that omnibus feel to it as well. So if you find statistically significant difference, you have to calculate standard residuals. And the residuals the formula is slightly different, but it's observed minus expected divided by the square root of expected. And interpreting the residuals, basically you're looking for a value greater than the absolute value of 2. So it's less than -2 or greater than +2. That's the major factor that contributes to it. That's the post-hoc analysis. So here's an example I believe you're familiar with already, and that's the use of the classroom practices record. That's an instrument that's used to examine the type of questioning that takes place in a classroom. There are 4 types of questions the classroom practices record posits that can occur. First of all, teacher can ask a higher order thinking question. The teacher can ask a knowledge comprehension question. That's sometimes called the lower order thinking question. Or the student can ask the higher order thinking, or the student can ask the knowledge comprehension. So if we think about Bloom's taxonomy, which is what's being used here, the knowledge comprehension questions are lower on Bloom's taxonomy. They're lower order. The application analysis and synthesis fit into the higher order thinking bucket. So here's an example. Based on experience, what would you expect the distribution of question types to be in a standard lecture format in a high school? What would you expect to happen? And you could put the higher order versus the the lower order, what do you expect to happen? And then you would actually collect the observed. So I worked with a student at one point who did a dissertation looking at reading strategies. It's Jason McKinnon. You can check out his dissertation if you want to by following the link here, and I'll link it in the video as well. And basically what he did was he had a treatment and a comparison group. And with the treatment group, he gave them some strategies for asking more higher order thinking questions. And so let's take a look at this data table. He did a pretest where he just went in classrooms, observed teachers, and recorded how many higher order thinking questions. And then he used the revised Bloom's taxonomy. So there's understand, remember versus knowledge comprehension, the same ideas. And so he went in and observed teachers, both that were going to be in his treatment group and comparison group, and collected that information. That becomes the pre or the expected. Then for treatment, he worked with teachers on asking more higher order thinking questions in the classroom, gave them strategies for it, and then went back and did a post analysis. We observed the comparison group, and he also observed the group that got the training and saw the differences. So now we can take a look at just looking at the data. Initially, he had 45 higher thinking questions, and then he got in the post 102. And so you can see the differences here. The teachers in the treatment group increased questions in the post that were higher order thinking and decreased the amount of lower order thinking questions they asked. And then the same thing happened with the students, significantly more questions there and less questions there. The comparison group didn't see that kind of change. He reports the chi-square value of 940. I'll teach you how to calculate that separately, degrees of freedom, and there was statistical significance based on that information. And so after you say, okay, we know something's happened, where did it happen? And so we look at the standard residuals, and anything that has a value greater than 2, absolute value of 2, has got a significant difference. So here we see 8.5, negative 8.36, positive 27.97. These are all statistically significant. This change in the lower order thinking of the students is not significantly different. The way you interpret that, obviously, is this is 102 is much bigger than 45. So this one went up, this one went down, this one went up. And then in the comparison group, the expected was 49. They actually went down even more. There were less questions overall asked, but these were significant. These were not. Here's one that you might think from a school perspective. You often hear the comment that underrepresented students are referred at a higher rate than non-underrepresented students. So here's one looking at the ethnicity of a school and the enrolled students, the percentage of enrolled students versus the total referrals. So if you were trying, now this is based on percentages. That's just the way the data comes from the system that I grabbed this information from. However, you always have to use n's, number of individuals. You don't use the percentages. But we can just look at this for a relationship to understand like how data might be used for a chi-square analysis, because here are categorical data and then the frequencies that fall into them. So percent of enrolled students becomes your expected. This is the number of kids that are in a specific school, where the blue is the total number of referrals, and that becomes the observed. So expected in green, observed in blue. So if we look at this group right here, we can see that Black students represent, I don't know, like 17% of the school population. However, they are receiving 25% of the referrals. So the question is this a significant overrepresentation of referrals to Black students? You do a chi-square analysis to figure it out. Eyeballing it, it sure looks like it. Like the Latinos they're a higher percentage of the school population there. But by looking at this, they're slightly under the population, so maybe they're not being referred as much or kind of what is expected. And the Pacific Islanders, the Asians look very similar. The multiracial seem to be overrepresented in the referrals, and the white students seem to be underrepresented in the referrals. You can do an analysis because this is not parametric data, it's categorical data. How many students go into each bucket? Does the expected match the observed? Again, always remember, use the number of individuals, raw data, not percentages. I did a study a number of years ago after the pandemic, and The question I was looking at was, there were a lot of equity issues associated with the pandemic. One of them was the way students were graded. A lot of urban schools decided to just pass fail kids, and students in high-performing suburban districts still give students percentage grades. And it made me wonder because I looked at a school who actually gave the students a choice. So the choice was if you want to receive just pass fail grades, or do you want to receive percentage-based grades? So the expected were similar to my referral situation, the number of students in the school. We expect so many students in each group to fit. And then the observed is the number of students in the question group, how many actually selected receiving grades or receiving a pass-fail situation. And so here's some results from that study. So I looked at high needs groups of students with low socioeconomic status, English language learners, or special education status compared to the non-high needs. And I also looked at ethnicity and race. And so what did I find? Students with low socioeconomic status, also in these racial groups or ethnicity groups, had a statistically significantly lower option of picking the percentage-based grades. They elected to receive pass-fail grades at a high level. And then the English language learners, same thing here. And then the high need students, the Asians and the white students, actually at a higher percentage chose to receive the percentage-based grade. So there was this imbalance. There's some questions around equity that might be able to glean from some of this. This was some very early data from pandemic learning. So what are we going to do? We'll do something actually kind of fun and exciting. We're going to look at M&Ms. And do the M&Ms in the bag represent what the factories say they're producing? So there's a short video linked in the video section here, also available on Blackboard, that will take you through me opening a bag of M&Ms and counting out what I got. Where I'm located now is closest to the New Jersey factory, so we'll do some comparisons to see if what is observed matches what is expected. So your job is to watch the M&M video and count the number of colors in each type of category of M&Ms, how many brown, yellow, red, orange, green, and blue there are. And after that, join back for the third video where we'll talk about actually how to do the calculations and analyze the information. All right, thanks.